Thank you everyone for being here today for TURN's launch of Australia's Environment Report 2022. It's so great to see all your faces. We are live streaming, so there are a lot of more faces out there that we can't see. And to start today, and in keeping with the spirit of reconciliation, I acknowledge the Aboriginal and Torres Strait Islander traditional owners and custodians. We honour their profound connections to land, water, biodiversity and culture, and pay our respects to the elders past, present and emerging. And today I'm joining you from Ngunnawal country, which includes the city of Canberra. So today in our audience we have many people from the federal government, from the Department of Climate Change, Energy, the Environment and Water, from the Department of Agriculture and Fisheries, from Education, from the Australian Bureau of Statistics. Very pleased to see our good friend Penny Wensley, the National Soils Advocate, who was at the last launch that I did. Thank you. We have members of CSIRO, the TURN Advisory Board, and many people from universities, national research management bodies. So again, thank you all for joining me today, and for those that haven't met me, my name is Beryl Morris, and I'm the Director of TURN, which is Australia's Ecosystem Observatory. We've got a good program for you today. We have got several speakers. I'll be introducing them to you as we go through. So we will have a couple of speeches, we will launch, and then we'll dive deeply into the report and learn a little bit more about that one. So first up, I have the pleasure of introducing Dan Donegan, who's the Assistant Secretary for the Research Policy and Programs area of the Department of Education. And it's wonderful just to have NCRIS being here today. Thanks, Dan.
Thanks, Beryl. It's great to be here. I too would like to acknowledge and pay my respects to Aboriginal and Torres Strait Islander people and pay my respects to their elders past, present and emerging, recognising the over 1,000 years of connection to and care for country, which is very relevant to today's launch. Beryl, thank you for your introductions and for letting us know who is in the audience. Today's audience also includes the National Research Infrastructure Advisory Group, and a number of stakeholders who are really interested in climate and environment. Today's audience reflects the need to continually strengthen connections to meet environmental challenges ahead for Australia. Today I'm here as the representative for the Department of Education because of its role in supporting research, whether to generate new knowledge, be translated into one of the many benefits research can unlock, or to inform and guide government policy. Most importantly for today's event, Education manages the National Collaborative Research Infrastructure Strategy, or NCRIS. Since 2007, NCRIS has provided open access to a diverse national network of equipment, services, data and data tools, and technical expertise to undertake leading-edge research. The need for a nationwide terrestrial ecosystem monitoring capability, or TURN, was one of the first NCRIS projects identified. The 2021 National Research Infrastructure Roadmap highlighted the need for world-leading research infrastructure to help protect Australia's unique environment and respond to climate change. This priority reflects how important TURN observations, data and products are for Australia, now and into the future. The 2021 roadmap did more than set out ongoing priority areas. It also included a set of recommendations on what it called the step changes. The 5 step changes are areas which could focus investment to deliver significant impact and make a substantial difference for Australian researchers and innovators. And climate and environment is one of these step changes. In achieving this ambitious step change, it will require collaboration across traditional disciplinary boundaries, bringing together climate modellers, environmental scientists, and other domains like public health to deliver new insights into the country's current and future needs. Like this report, it requires data, but that data must be accessible, computable, and inform decisions not only of government but of businesses. The need to build on this to achieve that step change in scale and pace of activities will be necessary to support Australia's long-term ambitions, and I hope everyone in the room will be part of achieving that. We're here today to launch Australia's Environment 2022 report, being a collaboration between TURN and ANU, and seeking to illustrate quality research and inform policy. It provides an example of the benefits of combining our efforts to understand and influence. So thank you for your time today, and I'll hand back to Beryl.
Thanks so much, Dan. That was excellent to see the power of NCRIS capabilities being acknowledged so publicly. I'm just going to talk to you a little bit for a moment about Australia's Environment Report, which we like to think that we're taking the pulse of the country 24/7, 365 days a year with all of our instruments and our people. But it really doesn't come back to anyone until you see something like Australia's Environment Report. It's spatial information, environmental monitoring data. Now, this data exists out there. Sorry. But finding and understanding that information and the data is not easy. In fact, working with them is even harder. I sometimes say you might need a couple of PhDs to get into some of the data that we have because it is very complex, integrating it and getting meaning out of it. And so you often need specialists to find it. But some years ago I attended a symposium that was put on by NCRIS in 2017, and it was the first time that I saw Albert van Dijk talking, and he was talking about the work that he was doing to try to bring this data together so that it didn't take you years to find that information. And obviously, if you or I, particularly me, was trying to find that information, it would be out of date by the time I actually pulled it up and worked out what to do with it. So 2022 report is a summary of the key environmental indicators and how they've changed. It's last year, it's the year that was. And Albert's been now releasing the reports annually since 2015, and they have been gradually picking up more and more data, integrating across the world. And it's allowing us to now track patterns of change in Australia's ecosystems and assess them and work out what's critical to understand and therefore feed it into how we're managing our environment. So the Australia's Environment Report complements that which is brought out every 5 years by the Australian Government, the State of Environment Report. It does allow researchers access to data more regularly on an annual basis to fill in until the next State of Environment Report comes out, so that they can monitor and analyse the trends in the years between. So if you go into the website that is mentioned in the books that I hope you've all picked up, you can see that there are models and there are data involved. And we have an explorer embedded into Australia's environment, which is created by analysing the long-term data from satellites and on-ground stations, such as those that TURN has, and then use algorithms and prediction models and couple that together with our NCRIS-enabled National Computational Infrastructure, NCI, colleagues, so that we can download the data sets via the Explorer, and you can go explore it later and see how that goes. And what's really fun is that anyone can use Australia's environment and the Explorer. And it makes it accessible, and I've seen classrooms using it in order to teach students how to handle spatial data, how to use CSV files, how to make pictorial representations of the data. That becomes very important in building capacity for the future in handling big data. I've also seen people print out their own postcode area just to have a look. I have a colleague who went in, and they live in Northern Territory, and they wanted to check whether there'd been any snowfall in their area, because that's one of the parameters that you can check. The report cards that you can pick up can be downloaded for any administrative or geographic region of Australia, including local government areas, electorates, bioregions, and so on. That's really important. We know that local governments make enormous use of it, and there's always a bit of a top-up of radio coverage straight after each annual report as local governments have a look to see how they've been going. We've actually set a printer up out near the morning tea so that you can go and ask Nicholas, who will be near the printer, to print a report card for you to take away if you wish, to get the latest information and go back and discuss it with people. So at this point, it gives me great delight to launch Australia's Environment Report 2022. And at this point, I'm now going to hand over to the person without whom it would not be possible, Professor Albert van Dyk, who's from the Fenner School of Environment and Society at Australian National University. And he's going to talk to you about the year that was and the findings that happened in our report. After Albert has talked, we'll also have a talk about a new feature that's in the report this year, with data gathered in a totally different way in the area of biodiversity. And when we finish that, we are ready to take some questions from you. So listen, there will be marks. Thank you. Over to you, Albert.
Good morning, everyone, and great you're here, braving the rain and the traffic to attend this briefing. Welcome to people online who I can't see, but must be there. So yeah, I'll take you through the findings of the report. And of course, I hope you've got a copy of the report, and you can find a lot of the detail that I won't be explaining to you in the report, but it's more maybe as a conversation starter about what we do and what sort of year we've been having. First, a little bit of global context, and I'm going through the same sequence more or less as the report, except I'll end with the summary metrics, because the summary metrics are a amalgamation of the thematic kind of assessments. So I'll first talk a little bit about global change. I'll talk very briefly, really just summarizing the key messages and maybe a graph here or there, and then later, of course, be happy to talk about it. The growth rate of greenhouse gases was less than the previous year, while global temperature and the ozone hole increased, and Arctic sea ice extent was the lowest on record. That is the summary on a global level. So while Australia might have had a relatively good year, we can't say the same globally. Things are still getting out of hand fast. We see no serious reduction in greenhouse gas emissions, let alone atmospheric concentrations. The ozone hole increased a bit. Now that itself doesn't have to be too worrisome. That has something to do with La Nina as well, and there's every reason to hope that we might go on continue on a stable or a reducing trajectory where the ozone hole is considered. But the ice caps are still melting. That hasn't gone away. Here's a picture of the global mean air temperature anomalies. You see the last 2 years were globally a little bit less hot than the years before that. Once again, there's a La Nina signal in there. But as soon as La Nina has ended, and that's around about now, we'll see that the oceans start releasing more heat again, and we'll see the temperature pick up. So while I'm here to talk about the year that was, sometimes I can make a safe prediction. a reasonably safe prediction is we'll see temperature going up next year. It's not going to go down. The oceans, despite record high sea temperatures, the Great Barrier Reef showed widespread recovery. There's a bit of a surprising message there, perhaps. So around Australia, and I think I got a picture of that, we had very high sea temperatures, and that's basically because the sea, pretty much all around Australia, was quite warm last year. There was a mass bleaching event in the Great Barrier Reef. Once again, it's been happening a lot, and it will happen a lot more often. Fortunately, the impacts didn't seem to be as severe as some of the mass bleaching event that happened prior to that. So there's a little bit of a silver lining there. When we look at people, of course, I'm not trying to suggest that people are good or bad for the environment inherently, although we're not doing a great job at taking care of our environment, obviously. Population growth resumed. That, of course, that means more pressure on resources, more pressure on space, more pressure on natural ecosystems, a greater desire to build houses, to clear land, and so forth. That is, we haven't broken that link, and that's why at the moment population growth is not good news for the environment. Australia's carbon emissions stopped declining, also not great news. Now these are data from Department of Environment, etc. And as we can see, it was kind of trending the right way, but since COVID has ended, we're not seeing a further reduction in emissions. Weather, of course, a big role last year, as pretty much every year. Rainfall especially. Rainfall was the highest in a decade, and for a lot of parts of Australia, the highest since at least 2000, and in some cases, Sydney, for instance, I believe in some cases the highest on record. So a very wet year across most of Australia, not all of Australia, but most of Australia. And on a national level, the wettest year since that quite wet 2010-11 period, and in some regions even wetter than that. Not quite so hot. That partly has to do with the rain. More cloud cover means less heat, less sun, less hot days. So it was relatively a bit cooler. But when we consider that it was a La Nina year, and you can compare that to 2010-11, you see that it was cooler back then. So what we're seeing is that despite the fact that La Nina and rain still brings relatively less hot conditions, we still see a trend there. It's still getting warmer, even in relatively cool years. Water then. River flows were the highest since 2011. That's on a national level. Of course, there is no national river. If there was, it'd probably be the Murray-Darling Basin, I suppose, the Murray-Darling River. But when we look at catchments, we see that some catchments, including several catchments within the Murray-Darling Basin and along the east coast, had very high flows. The highest for the 20 years that we've measured, but certainly also in many cases you can go back much further before finding a big flood like that. Now that's good news for water resources, dams filling up and so forth. It's good news for wetlands, lots of inundation, lots of water turbidity. It's not always good news for the people who live along the river, of course. There's been a lot of homes being flooded, a lot of businesses being flooded. And here's a picture of inundation. So what has actually flooded? The area flooded was actually not quite as high as 2011, but that's because in that year we saw a lot of flooding in the outback, basically in the Lake Eyre Basin and so forth. And this year that was still occurred, but it wasn't quite as extensive as in those years. But when we look at Eastern Australia, Murray-Darling Basin, the East Coast, we see typically the highest inundation, highest flood levels extents since at least 2000. Soils. Soil moisture and soil surface condition improved across most of Australia. When it rains, the soil retains more water, the plants grow better, the plants cover the soil better, they produce litter, the litter covers the soil better, so we see better soil protection in a nutshell. Looking at soil moisture first, we see that not everywhere did soil moisture increase. We see parts of the Northern Territory, parts of WA, and Western Tasmania that kind of missed out on the big rains that the rest of the country has seen last year, and soil moisture did not increase. It's not in all cases was it particularly dry in those areas, but certainly not as wet as the year before that. When we look at soil exposure, the lack of protection, the other side of the same medal, we see that some parts of Australia, particularly inland WA and kind of Northern Territory or Gulf of Carpentaria areas, they actually didn't have such a good year at all. The monsoon wasn't so great at all in those parts, and there is also something going on. We're still looking into what exactly, but in inland WA, there is some signs of ongoing decline in vegetation and in conditions, and we're not quite sure what's causing it, but it's certainly something we're looking into, because climate alone doesn't really explain that. By the same token, we see again in Eastern Australia and also along the WA coast that soil protection and soil moisture conditions were good. Vegetation condition improved to levels last seen in 2011. You see, I'm repeating myself because, of course, all these things are linked to each other, and it's actually when they're not linked is when we start asking questions, as I have been a few times so far already. Carbon uptake has probably been the highest since at least 2000, possibly the highest ever. That's not something I can prove, but what we do see, there's a signal of CO2 fertilization. The increasing CO2 levels do mean more growth, and it's quite possible that last year saw the highest carbon uptake. We do know that the terrestrial biomass or the vegetation effectively takes up some of the emissions that we produce. And we see that back in high growth rates. So there's, once again, there are some silver linings to that very dark cloud. Quite possibly related to that, but probably not only related to that, woody cover has been increasing certainly last year in many parts of Australia in line with wetter conditions, but also in the longer term in some regions we do see an increase in woody vegetation cover. Let's say tree cover, but something that looks like a tree anyway. Fire activity was low 2022, no surprise there, of course. As long as the soil is kept wet, fire's not going to get a foothold. As long as we don't have heat waves, fire's not going to get a foothold. So that is easily explained. Fire emissions, this is the area burned. There's always some area burned, particularly in northern Australia. There's always areas being burnt there, and last year was no exception, but it was below average. And in fact, there's a picture of the areas that did burn. Usual suspects, really. So what does all that mean for biodiversity? Well, of course, it's not a straightforward link, and I'm sure Jeff will talk more about that. Climate and weather definitely influence abundance of species, but they don't necessarily have that much of an influence, or they're not the only influence on the survival of species. There are two big other factors here, of course, habitat destruction and also the invasive species that affect many of our threatened species. A positive year doesn't really change that underlying trend, as Jeff will talk more about, and I don't want to steal his thunder, so I'm going to probably quickly skip through those graphs that might be there. But a third wet year did help post-fire recovery, and when people ask me, so it was a good year, my answer would be it could have been so much worse. If it hadn't been for the good rains the last 3 years, our fire recovery would have been seriously hampered, and it has been very good, and it has helped burnt areas recover. Wetland communities really needed that drink, really needed that flooding, and by and large they got it. So that too is a silver lining, if you like, at least for now, a good news story. Unfortunately, it's not good news everywhere, of course, and certainly in terms of biodiversity, our threatened species are not doing any better for being recognized as threatened species. They're still going backwards fast. On the whole, we don't see big improvements on their trajectories, but Jeff is going to put some more detail, a bit more sophistication around that, because there are, once again, some good news kind of, or some positive aspects to that. But, these numbers are quite shocking, really. Since 2000, the abundance of some of our threatened species has gone down by, on average, about 2/3 or nearly 2/3, and that's quite shocking, of course. It means that we're not able to stop it. And here's a picture of what that looks like. and I think Jeff will talk more about that. We see one apparent exception, the mammals, and maybe one part of that is another good story, is that the humpback whale has been taken off the threatened species list, has been doing fantastically since we stopped whaling, and it's a clear example of how direct action can have direct benefits, in some cases anyway. So the summary then. Red is good. I mean, the red is bad and green is good, as you'd expect. And I do appreciate that if you are colorblind, this might not come across too well. So I do believe we have tried to take that into account. But on the bad side, the ozone hole increased a bit from the average of 2021. That's what you're looking at here. So is it below or above the average for the last 20 years, let's say? So the ozone hole is a bit bigger. Ocean temperatures have gone up, population's gone up, threatened species, the number of threatened species, what we're looking at here, has increased. 30 species were listed last year, mostly as a consequence of the Black Summer fires. On the positive end is pretty much everything. Temperatures were a bit lower, hot days were a bit lower, rainfall, biomass burning was less, river flows were better, wetlands were inundated more, soil moisture was up, soil protection was better, vegetation density, leaf area was up, plant growth, so the extraction of CO2 from the atmosphere was up, and tree cover was up. So a bit of a mixed story, but on the whole a positive story, and we see that when we calculate a composite indicator, very much comparable with macroeconomic indicators. Of course, they are based on some questionable assumptions. There's some indicators that correlate strongly with each other, and in fact, because they correlate so strongly, it doesn't really matter too much how you add them up. You get the same sort of patterns. So a good year, once again, the best since 2011 when we look at a composite score. And you can find details in the report, happy to talk about it. And that composite score is once again here shown as a kind of a state of origin map, I suppose. And New South Wales won again. So we've seen really good, on the whole, good environmental conditions in New South Wales and Victoria and ACT, probably the least good in Northern Territory due to the lacking or the not so very good monsoon conditions there. And I think with that I'll leave it for Jeff, if I'm not wrong. Okay, the report cards, I think Beryl already mentioned that. So there is of course one for the ACT that you can pick up outside. Okay, I'll hand over to Jeff to talk about the Threatened Species Index, which for the first time this year we've been able to include in our report, and we're very happy that we can have been able to do that.
Okay, thanks Albert, and thanks everyone for coming. My name's Jeff Hurd. I am the project manager for the Threatened Species Index, based within TERN in Brisbane, and it's a great thrill for us at the TSX, as we call it, to join the Australia's Environment Report for 2022, the first time that the index has been included. So I thought I'd take the opportunity today to give you a bit more insight into the index itself, how it works, and hopefully leave you with some inspiration to go and use our visualiser to dig a little bit deeper into the trends that we produce at the national level. Okay. So, what is the TSX? It's fundamentally two things. Firstly, it is a repository of monitoring data, long-term monitoring data for threatened species that's been accrued across Australia over recent decades. We see that as very much one of our core missions, to be this centralised repository where we can collect up this crucial data that's been collected. Huge amounts of funding, of course, huge amounts of effort has gone into collecting this long-term data. And we want to be the home of that information and make it available for generating trends as we do, but also for other uses, such as in the Australia's Environment Report. So we have a call to people across the country, and we go hat in hand and ask them for their monitoring data. In this case, for example, monitoring data for malleefowl from Yucumara in South Australia, and they'll give us estimates of the number of nesting mounds that they see each year, and we collate that information up and integrate it into our trend calculations. So we pull all of that information together to produce these estimates of abundance trends through time, And we do that, as I'll show you, for multiple different levels. We do it for different groups of species, we do it for different jurisdictions, and we can do it for both threatened and near threatened species. And I'll drill into this a little bit further. Okay, so I thought I should give you a very brief history of the TSX. So the TSX started under the Threatened Species Recovery Hub, funded by DECU, of course, then DOR, and it was initially a collaboration with BirdLife Australia. So it started life as the Threatened Bird Index, and since then, so starting in 2016, since then mammals and plants have been integrated into the index, and we are working on including additional groups going forward. So frogs are the next group that we hope to integrate. So in 2021, the funding for TSR Hub wrapped up, and we were thrilled that it could be taken over by Tern, brought into the NCRIS fold, and really made part of our national environmental infrastructure. And I'd just like to acknowledge the ongoing funding of DECU, and note that also the index has been integrated into DECU's corporate reporting. So we're really thrilled that the measure is actually being now used as an objective assessment, I suppose, of how our investments are going, our national investments in threatened species. Okay, so since that time, so 6 years of data collation now. We did a big data call last year, and we now have 278 species included in the index, almost 20,000 time series, which is quite an extraordinary number now. Almost 11,000 sites across Australia, including our offshore territories, Ashmore Reef, Christmas Island, Norfolk, Lord Howe. And we've got those three major taxon groups, as I mentioned. On all those photos there are meant to indicate just the breadth of data that we can incorporate into the index. So you might be doing a line transect for plant cover, you might be doing camera trapping for threatened mammals, you might be doing a bird survey. We can integrate all of that data and include it in our estimates of trend. Okay, so that's our process. Fundamentally, we go out, we ask for data from across the country, we pull that all together into our database, and then we run our estimates on a supercomputer to work out all of our trend permutations. And then every year we load these onto our visualizer page. Yeah, you can dig into the trends further there. One really exciting development has been the use of the TSX now in the State of the Environment reporting. So this is the 5-yearly State of the Environment reporting. The TSX was included for the first time in 2021, which is a great thrill. So it's now a key biodiversity metric within the SOE. And of course now being integrated into the annual State of Australia's Environment report, which is really terrific. We're really glad that we can contribute to this initiative as well. So I thought I'd just end by giving you a little bit more insight into how you can use the index to explore some of these trends. So this is our visualizer page. And here you can see the ways that you can subset the index. So you can look at different groups of species, those three that we currently have. For any individual group, you can look at subgroups, so you might be interested in what's happening with terrestrial birds or perhaps herbaceous plants. You can drill into that. You can look at your particular state or territory that you might be interested in. You can subset by what we call status authority, so whether it's listed under EPBC Act or under the IUCN Red List. You can look at all species or just near threatened species or just threatened species. And you can also change the reference year. So our default is 1985. For Australia's Environment Report, we're using 2000 to match with the approach that Albert's taken over the years. And just at the bottom there, you can see you can download your trends, you can download data summaries, and you can also download the data. So the data is made freely available. We redact some sensitive information, but if you so wish, you can download the CSV and then do all sorts of additional explorations. Okay, so subsetting through the different groups, we have all. So this is for 1985 onwards. You can subset for birds, of course, mammals, and plants. As Albert mentioned, there is a bit of variation there in between how these groups are tracking. So birds are similar to the main index, a decline of about 50% since 1985. Mammals are quite variable, and some of them are doing very well indeed. So Albert mentioned humpback whales, southern right whales are doing really well. Some of our critical weight range mammals are doing very well indeed. And you can see that in, so the grey here is a confidence interval. And so some of these trends are right up here at close to doubling of abundance. And so those are particularly critical weight range mammals that are in reserves or in populations that are getting lots of baiting. So there's good news in there. For plants, the trend has been one of fairly steep decline, but as I'll show you in a moment, there is some hope in that data as well. Okay, and the hope comes from management. So I just wanted to point out, I wanted to end on the data that we have with management. So for mammals and plants, for every time series, we know whether that population is managed, actively managed, or whether there's no management or it's unknown. And so we can group those up into sites that are actively managed or at which there's no known management. And I just wanted to show you the data for mammals. So this is the blue. I've failed to mention that the blue is the average line, and then the grey is that confidence interval. You can see that for mammal populations that are actively managed, they're actually stable. So management is slowing declines, and you can see through that confidence interval again that some are going gangbusters under management. So there's good news there, and if you compare that to those with no known management, it's a story of, on average, continued decline. So we can stabilise our threatened species through management, and the TSX is proving that that's the case. Okay, so I'm going to end there. Hopefully that's a little taster for the visualiser. Please jump on and have a look, and look forward to talking further after this. I'll hand back to Beryl.
Thanks, Jeff. So you got to see with Albert's talk that there is a lot of data that he pulls from all sorts of machine-readable data sources, etc. And then you saw in Jeff's talk that we have a fleet of people across the country on which we're reliant. Data comes in all sorts, it's all good, and the important part is that we can see the trends that are happening. Those pieces of information about 2022 probably wouldn't mean very much until you saw those graphs that were presented of the timeline that's been happening. So where do we go from here? Actually, you didn't know that you were going to be part of our focus group. We're really interested to hear about what you think are the important parameters that we should be monitoring. Jeff's mentioned that he's going to move into frogs. It's no secret that he's a frog person. But he did actually do a survey and found that people wanted frogs to be the next cab off the rank for monitoring. And we have a good number of parameters that Albert has honed in on, but we do hope that as time goes on that we can pull more information out of the NCRIS capabilities and put that into the report. And we also hope that apart from expanding the amount of monitoring of trends that we're doing, that we can get to some situation of prediction, because prediction is obviously what we all want. It's very nice to look back, but the world is changing so fast that where we've come from may not be an indicator of where we're going. And so we do want to be able to develop a dynamic environmental prediction system, which helps people to carry out all those forecasts that are needed for impacts of weather and flood and fire events and natural resources and the state of our ecosystems. So we are going to open up for questions now, and feel free to put in your own request. But before I leave, obviously producing such an enormous amount of work, which looks just simple when you put it into a document, as we've seen today, or you point to a well-managed website, it doesn't show how much has been done by all of the people that are listed in the production list here, and I'll let you read those through. And you will see the amazing list of organisations that we have tapped into to pull data, and we're very grateful for the fact that people make that data freely available to us. So we are now going to ask you for your questions, and also to remind you that as we wrap up, you'll be able to get a report card outside. So, do we have any questions? Oh, Greg, thank you. Sorry, start with.
Thank you very much for the overview. It's a fantastic report, and congratulations on keeping the time series of the reports themselves going too, because we know how important that is. Beryl, picking up your last point of prediction, just be interested to understand a little bit how might that prediction work, and what do you envisage the results might sort of look like to incorporate in the report?
I'm going to hand to Albert.
That's a really good question. There's no doubt that we can predict certain things into the future. Some of them we can predict because there's a very strong trend and there's nothing on the way to change that trend. So that becomes a bit of a no-brainer, I suppose. Some things we can predict if we can predict the weather. Now that's always going to be difficult. And so I think we're back to what the Bureau of Meteorology is able to predict. And if they can predict if it's going to rain, then we can predict a lot of other things from that. But the question then, of course, is what of those things are useful predicting? Because we can also just stick a finger in the air, and if it's not going to change our decisions, then the prediction, certainly a quantitative prediction, is not that necessary. So I think there's been quite a discussion about environmental prediction for a while now. And I guess the real question is, what is worth predicting? What would we really want to know in advance? So a good example is, for instance, there's been a lot of discussion lately about if it's going to be an El Nino year, are we going to see potentially the same sort of fires as we saw in 2019? Now, I have not done that quantitative prediction, but I can make a pretty strong statement that that would be unlikely because the forests are too wet to basically allow that sort of scale of fire to happen, in 1 year. That doesn't, there's caveats and everything. So there might be, if it's an extreme year beyond anything imaginable, who knows? But on the normal hot conditions, climate change included, that shouldn't happen. So, and that is useful news, of course, for fire agencies to do some planning on. So. Maybe that gives you some idea of some of the limitations on prediction, but also some of the opportunities.
I just want to add to that before we go to the next question, that obviously being able to maintain our time series observations is really important. We know that during COVID, when we were prevented from going into the field and so on, it was so frustrating because change was continuing. What we weren't being able to record was the direction of the change and the magnitude of the change. It's impossible to go back and get the figures that you miss. And so I just put a plug in for the importance of long-term monitoring. Now we have a question here.
Oh, thanks very much for the presentations. Fantastic. I'm Annie Lane from the Australian Citizen Science Association. And I'm just wondering about, so we talked about water flows, but I'm wondering about water quality, which is obviously a very important consideration, not only for the environment but also for people. And, there would be obviously a correlation between flows and quality, but depending where you're picking up your information from. And the second point I was wondering about, and Albert mentioned that one of the still major threats to biodiversity are invasive species, whether there's an opportunity to include invasive species in the report. So we saw vegetation cover increasing. How much of that might be due to invasive weed species, for example? So we saw, with the recovery from bushfires, for example, a lot of weeds come in and provide that ground cover, which is maybe a good thing or a bad thing. So whether there's an opportunity to have some sort of indicator of the trends around invasive species. Thank you.
So I'll let Jeff answer the question about invasive species monitoring, because that's more his bailiwick. I'll just quickly answer the question about water quality. Absolutely, of course, it is important. It is also highly variable and not very well measured, and certainly citizen science is an important way to improve the current situation, because I don't see state governments quickly expanding their networks. We've seen last year high rainfall also raises water quality issues, because floodplains get inundated and wash off organic material, and we're now seeing fish kills in Menindee by and large as a consequence of that. So I guess in terms of water quality, you can have too little, which is poor. We had the fish kills before during a very dry year, and now we've got them after a very wet year, so you can't win. But it's an important parameter. Of course, water quality is such a complex topic because there's so many aspects to water quality. We don't report on it because we can't really paint a clear national picture. The Bureau of Meteorology, on the other hand, does report on it in their water assessments. So that is one source of information on that. And then on the invasive species, I'll just answer the question that regrowth, yes, it can be weeds. We can't tell what is regrowing. You're absolutely right. And so in principle, it's possible that it's undesirable. That is certainly true. And there are always caveats on data to consider like that. And it's possible that invasive species benefited more than threatened species in other cases as well. There's always something to be trying to keep a close eye on. The only way to find out is to actually try and go out there and monitor that. Yeah. And then for the abundance story, I'll give it.
Thanks for the question. Yeah, you've actually got me excited about an IPX, an invasive pest index. Maybe we could pursue that in future. Yeah, I think there would be scope for it. And Steve and Ashley might want to chime in here. But so one thing that DeQ and Turn are working on at the moment are standardised protocols for monitoring of invasive pests, and that would give us the foundation for gathering up that abundance information and producing an index of trends. I think that would be really useful. I'm not aware of it being done at the moment, but there might be some state-based things happening on that front. I'm not sure, but I think there's definitely scope for it, and it would be very useful. It's a good point that invasives can boom under these conditions. Carp, for example, are in the Murray-Darling Basin at present. In terms of our own data, we would love to be able to link. That is another driver in the threatened species index and we know that for some populations, the management, of course, for some populations that are included in the index is regarding invasive species, so particularly those mammals. So there's an opportunity, I suppose, there for us to gather up some of that information. We already have it in some cases. There's some definite possibilities to go forward with on that front. Just while I've got the mic, I might loop back to the previous question, which was about prediction, and that's something that we would love to do with the Threatened Species Index as well. So I showed you management as one driver of population trends, but of course there's all sorts of other drivers relating to habitat condition or habitat destruction or just climate. And we think there's an opportunity with this extensive database that we've created now to drill into that data and tease out some of those drivers a bit better, and then ultimately in terms of prediction, we could look at how different management investments might change our curves into the future, and under different sort of climate scenarios as well. So I think there's a lot of scope for us in that space as well. Yeah.
And I have a bit to add too, and that is that Turn belongs to a global network of continental level observatories. It's called the Global Ecosystem Research Infrastructure. And our colleagues across the world actually have invasive species as one of their planks of observation. When Turn started in 2009, we felt that our resources just didn't stretch that far. But with citizen science, I actually think that we've got a good way of now embracing it, because that wasn't on the table back when Turn started. And so I'm very much endorsing what Jeff is saying, that invasive species would tell us so much about where we're, the consequences of all the management activities and the trends that are happening each year with the change in the environment. Okay, any more questions? Yes, we have Troy. Yes.
Thanks, Beryl. So we've got a few people here from the Department of Agriculture, Forestry and Fisheries, and one of the things we've recently done is, a few years ago, is launched the National Soil Strategy. And one of the key things we're looking moving forward is considering how we develop a framework for national soil health indicators. And you mentioned today a couple of those indicators you're looking at as far as turn, around water holding capacity, around things like soil coverage and so forth. Moving forward, what we want to do is get a level of agreement of what those indicators are so we can maybe potentially monitor them. Just from a turns perspective, what are the key indicators you think are important to understand trends and how they might sort of link or I suppose relate to other factors such as obviously water quality, ecological systems and so forth?
Is that for me? Yeah. I think with soil condition in particular, there's a big difference between what you want to know and what you can measure. There's a lot of things we want to know about the soil, and they're all related to soil health in different ways. I suppose different indicators of soil health and soil functioning. We want our soils to have a healthy soil ecosystem. We want them to store carbon. We want them to support agriculture, and unfortunately, very few of those measures are amenable to large-scale measurement. Most of them involve digging, and so I guess from my perspective, when we talk about soils, we talk about the things we can talk about, not the things we'd like to talk about. We can't. Of course, we'd want to know very much whether soil carbon storage is changing, and if so, by how much. It's critically important, of course, to understand that. But that is not something that we can provide national scale information on. So that is, I suppose, a critical limitation. Nonetheless, there are ways through a combination, and there's been a lot of work as well, through a combination of a solid monitoring net, a ground monitoring network, and combine that with spatial data on weather, on geology, and so forth. There are good ways to get reasonable estimates. We haven't seen the level of effort needed to make that happen. So here's hoping that that might one day happen. Yeah. Does that answer your question?
Thanks, Troy. Hamish, I think.
Thank you. Thank you, Beryl. Hamish Holler from the ARDC. Congratulations on the report and also on the Threatened Species Index and extending it to other mammals. My question is, these are large data integration and assimilation activities from multiple domains and multiple disciplines, and they're really focusing on our excellent infrastructure that we've got at the moment in observation and data standardisation. Going forward and thinking about dynamic prediction, what do you think are some of the challenges that we need to overcome as a community to enable that future functionality?
I can have the first go at that. I suppose it depends on what we understand prediction to mean. So there's predictions of what will happen if I do this or that. We do that all the time. That involves simulation models. Simulation models, of course, require infrastructure to make predictions, but they're not time critical, and that they can typically you can kind of cut the cloth in some ways. On the far other end is a sort of work that the Bureau of Meteorology does every minute of the day, which is short-term prediction, assimilating all these observations for all these different platforms in an operational way, and getting a prediction, an absolutely time-critical prediction of what's going to happen in the next hour. Now that, of course, is a big part of what the Bureau invests in and what they have to maintain. So I think I can't answer the question without really getting into what are we trying to predict, and how soon do you need to know it, if you like, right? And how operational do you need it to be? So in a general sense, operational short-term forecasting systems very compute, very data intensive, very high demands on reliability. When I predict something for what's going to happen in 10 years, well, I've got a few days to do that. If I want to predict what's going to happen next month, probably still maybe got a day or two. If I want to predict tomorrow, well, I better be quick. So it needs to be fail-safe. So sorry for not giving you a clear answer, but it gives you a range of answers at least.
Yeah, hi. Nicole Coombe from Department of Agriculture. I'm just wondering how this sort of effort, and it's sort of nationwide, continent-wide effort, compares globally. You know, are there other countries that are undertaking this sort of effort and with this sort of, I think, really great result?
Before he jumps in, I'm going to say I don't know of any that do it as well as this. But go, Albert.
You do or you don't?
I don't. I don't.
Right.
Don't.
Variable, I think. There are countries. I'm from the Netherlands myself. It's a small country that somebody lives everywhere. There's somebody that and in many, even though there's a challenge there too to get citizens out to do citizen science, there is pretty strong, in the UK similar, observation networks. So they know quite a lot about threatened species, for instance, and that's maybe the end where people on the ground make the difference, right? In Australia, it's a similar story with rainfall. There's areas there's an area the size of France in Western Australia where there's not a single rain gauge. Fortunately, we can actually estimate rainfall by satellite quite well, so we still have an estimate there. That's not the case for biodiversity for species. We can't. I guess you can always make a prediction, but they're far harder to predict. So I think there are countries that, in aspects, and there's also states in Australia that do better than the nation as a whole in that sense. Of course, there are good examples. I think, in some ways, we show what you can do in a country with a relatively sparse on-ground infrastructure. So I think we make the best of spatial data, of satellite data. I think we're quite advanced in some ways in that sense, and I guess Australia's got a long history of sort of shoestring science, making the best with very limited data. So in that sense, I guess that could be a good example for the many other countries in this world that don't have that very intensive infrastructure. Jeff?
But Albert, sorry, but they don't print out a report or launch a report every year. We're pretty special, aren't we? Tell me we're special.
I think so. I'm not in this form in any way. In any case, I don't think there's a report like this anywhere else in the world. But of course, there are institutes that report on aspects of what we report on a regular basis. Maybe not every year, particularly things don't change that fast. But in some cases, quite regularly. So I think you're right, Beryl. I think that this in this shape, in this level of integration, I think you're absolutely right. I haven't seen it anyway. But there are countries for sure with more intensive monitoring infrastructure, and so that's a benefit to them. It makes it easier.
Thanks, Albert. Ashley.
Thanks, Beryl. Look, great talk and all. We've been all touching on ideas of data and prediction and sort of what we can say with the data and what we want to predict. I think at the national level, we can use satellite data and get that good national level data. Where Jeff Space is going in the threatened species, it becomes more ad hoc. The species that are in there, there's only 270 odd out of the 2,000 listed. There was no real strategic nature of those being in there. They just happened to be what we could get data for. If you're looking at moving into that predictive space, has there been a strategic think about what sort of on-ground biodiversity data, because that's really the limiting factor in all this when you're moving to environmental predictions. Has there been a strategic look at what sort of data we actually might be able to collect, not what we want necessarily, but that low-hanging fruit, at least initially, and how do we start to move that from the ad hoc realm into the more systematic national realm? So like the Bureau of Met, we can start to actually make sensible predictions on data that we've gone out and chased.
Excellent question, and I'll get Jeff in a second, but around the world, of course, all of our observatories that are working collegially are all trying to come up with agreed standard measures, agreed essential biodiversity variables, and biodiversity is the most difficult area to work out what are you going to count as an essential variable to monitor them. And so there is, first of all, global conversation happening so that we can come up with something. And one of the difficulties we have in turn is that when it comes to biodiversity, there's a complete diversity of groups that are monitoring, and it semi-excludes a group like TERN covering things because we just don't compete or repeat what is already there. And so it means that you have to have conversations with large numbers of groups to get any sensible agreement on what the standard measure will be. But Jeff, your thoughts?
Yeah, I think that's a really great point, Ashley. And that's something that we would love to pursue with the TSX database. We now have, as you say, a database that's built upon pulling together information that we get, and so it is ad hoc in that sense. But we now have the capacity to really drill into that data set and do a gap analysis, so spatial, temporal and taxonomic, and find out where across Australia and for what particular species we need better data. And so use that as a basis for coming up with that more systematic approach. And I think that loops back into the prediction question. We do need that as a foundation. We have great information, and I'm thinking specifically here in the biodiversity space and the TSX. We do have great information, but it will be limited in its predictive capacity based upon purely where it is and its coverage and somewhat of the ad hoc nature of it. So, and then it links back to citizen science as well, because I think if we can use citizen science to then, once we've got that information about where our gaps lie, we can direct citizens to fill those gaps for us where possible. I think there's great opportunities there, and I spent a couple of years in the UK, and that's very much what they had running for invertebrates and birds. They had very systematic programs right across the country, giving them that really in-depth coverage of the species and spatial coverage, and getting really rich information that would be the basis for some strong predictions about future trends. So yeah, I think there's lots of scope, lots of opportunities there. Yeah.
And we have, I think, our last question down here.
Okay, thank you. My name is Terry Corn. I'm just an interested member of the public and a long-time receiver of the TERN newsletter. I used to work in this area. I want to ask you a question about the impact of your reports, especially with large industries like mining or agriculture. Do you have any measure of whether they seek your reports, and if they do so, how they use the information effectively to change their management?
Thanks, that's a great question. So we don't ask people to register to download our data or look at the data, and that is really to make it as easy accessible as we can. We don't want to throw up any hurdles in that regard, and I'm glad we don't, because who knows, our database might have been hacked by now if that was the case. So I can't give a very definite answer to you. It may be. I do know that there are companies that use our data often to get some kind of baseline environmental awareness or situational knowledge. What does the landscape look like? where we're working. I know that because I get questions about it, and that's generally true. I only know when people use our data when they ask us about it, and that's great, of course. So yes, we had the old mining company. Often the environmental groups within those mining companies ask us about, for instance, when a particular wetland might have flooded or some such, or a particular area might have flooded. So it has some impact there. We get I get a lot of questions from NRM groups, natural resource management groups, one way or other. Be they catchment management authorities in Victoria, be they groups in Queensland or New South Wales or Tasmania, or anywhere really. So most of those groups are if you like, remnants from our past environmental framework. We had Landcare, of course. We had some great initiatives in Australia, but those groups still exist, and they use it for their own environmental, sort of their own reporting, if you like, and trying to get a sense of what how their region is travelling, whether their activities are having an impact. One thing we do not provide at the moment, could potentially probably provide, is for instance, the extent of environmental plantings, which is something that we get a lot of questions about, understandably. Native vegetation loss, so we only report on total tree cover, not on the actual loss or the gain of an ecosystem. So maybe there's one answer for you already, one suggestion. So we know people use it. We know it gets used in education, as Beryl said, just to create awareness. But I guess my hopes would be on the next generation. I guess our overall intent is especially to create awareness about environmental issues, engage people hopefully in it, engage them maybe in the local Landcare group, or else at least bear it in mind next time they go to a voting booth. Yeah. So that's a roundabout way of trying to answer your question.
Thanks, Albert. And I did say that was the last question, but what I really meant was that was the last question with microphones, because we are going to move out into the foyer where there is some morning tea waiting for us, and our report cards if you wish to order your own customised report card. You go see Nicholas, who's over here, who's been handling our live streaming. Thank you so much for coming along and making this an event for us. So much work goes into it over the intervening time between launches, and it's just such a nice thing to have a tangible piece of evidence that we have got some trends, and we've got a lot of people who are willing to make use of those trends as we all care for our environment under a changing climate and world. Thank you once again for coming. Please join us in the foyer and we'll continue the conversation.